thank you very much for having me. Hi, my name is Martin. As Bartek said, I will be talking. I will tell you the story how we built internal monitoring platform using Prometheus in our company. Just quick note, there will be huge walls of text in the presentation. I'm sorry about that. I don't expect you to read that. I put there the QR to the slides. I expect you to read it if you find it interesting, the talk. I just couldn't help myself and left out the information. So, who am I? Former developer, now team lead building the monitoring platform in our company. I'm from Czech Republic, live in Brno, and I work with Prometheus since 1.6. And where do I work? Where we are building the platform? What's the environment we will be talking about? There's something like 800 developers. We are something like so-called Czech Google. We have our own full text search, news. We provide free email. We provide a whole ton of services. All our infrastructure is running in on-prem in physical data centers. Two of those are our own. We are building third, I think. And we have our own internal cloud platform. There are some stats, 150 Kubernetes clusters, 14,000 physical machines. This is our mascot, the dog. It's called Krusty. So, how it all started. When I joined Seznam, there was no application monitoring. It was, you wrote some code, packaged it as Debian package, went to the ops, and they deploy it, install it under the server, and then you were both looking at the logs tailing and waiting for the 500s to show up or not. And then Prometheus occurred, which was nice. We could have monitoring. So, now the boom, everyone is starting its own Prometheus, and it's all over the place. And the setup evolves. New projects are coming up, like Tunnels, Cortex at those times. Those were the first. We were quite heavy users of Tunnels. There was plenty of Tunnels clusters deployed in the company. But with great power comes also the difficult parts. You have to maintain this monitoring stack. You have to upgrade it, debug all the issues. You need to follow the upstream, the news. You have to come to the PromCon and hear about the news you need to deploy. And this was done multiple times in the company. Everyone was doing the same thing. And the question is, who will maintain all those monitoring stacks? Of course, it's fun to set it up, but no one wants to run it in long term. So we decided, since we have the internal platform in Seznam, that it's time, finally, to build one monitoring platform that would serve the developers, and they won't have to run their own stacks. And what were our goals? The main thing for us was to be easy for the developers to start from the point they deploy their application to get the metrics and alerting. So it should be easy to configure and to deploy. Also, we wanted to separate the tenants. Well, we have the company is separated to some divisions. There are some services like for the end users services. So we wanted to separate those metrics as a separated tenants in our platform to minimize noisy neighbors, because probably you will also bump into issues with cardinality issues when there are some leakage of unique values in metrics. And this will impact all the users of the platform if you don't separate those. One thing is also we have something like internal billing. So we wanted the separation of the tenants also for this building part, and some resilience and authentication authorization, of course. So the first thing was looking at who are the users we were targeting. Well, there were developers, and there were infrastructure people, the other cloud services, internal, and they have their own metrics. So we were primarily targeting the developers. And the default setup is running in Kubernetes in our company. As you saw, we have 150 Kubernetes clusters. So it was Kubernetes all over the place. So we had to target those. So how we will do the service discovery? Till this point, we used mainly Kubernetes service discovery using annotations, on pod annotations, and then provide some relabeling that would do this. It's really simple for the users. If you have just one endpoint exposing metrics in your pod, you just add the annotations to the deployment. It's just done. You state the path, you state the port. The unfortunate thing is when you need, for example, if you run some third-party software and you cannot control what metrics are exposed. If you want to drop some labels, you need to apply relabeling. But using annotations, this is not possible because you have one scrape job for the whole Kubernetes cluster, supposedly. So it would be global or very difficult. So this is one downside. And the hardwired label schema, you cannot add your labels to this. On the other hand, there's prometheus-operator, which makes this more configurable, but you need additional custom resources in your Kubernetes, and you end up having a separate scrape job per the monitor, which might impact the Prometheus. Next thing we needed to decide, should we alert locally or not? As you see, the best practice is to alert as close to the application as possible. So you should alert on the Prometheus scraping the app. Because if you put a remote write or something, some more infrastructure, some federation, whatever, it could all fail till you alert on the metrics. So this is the best practice and sounds reasonable, right? But at the same time, everyone embraces remote write with the agents and just sending it all to the central storage. And seems like nobody cares about the best practice anymore. We decided to stay with the local alerting, so that meant we need to provision Prometheus in the Kubernetes cluster. And to use remote write or not, formerly we used Thanos, and without remote write, which was funning out all the queries to all the Prometheus, collecting the metrics, the most recent one, and then just the older data querying from S3 or some object storage. Well, both of them has their pluses and minuses. With a remote write, you don't, if you query the most recent data, you don't need to fan out all the queries to all the Prometheus, and don't need to fetch them multiple times. You just query the internal central storage. On the other hand, it has other pitfalls we fell into. But we decided to go with remote write since it was mostly adopted everywhere, and we were afraid of the fan out of the queries with Thanos. Next thing, should developers manage the Prometheus? We said nope, because it's still no easy task. Even with Prometheus-operator, it can be hard. There are still some issues you might bump into. So yeah, we wanted to manage the Prometheus for them. And the other part, alert manager, yes, definitely. Grafana instances, yeah. push gateway. We didn't want to, but ended up doing it. It's not made for global deployment, but developers insisted, so we'll see in the future. We would like to provide some external monitoring for the developers. PromLens, we deploy it for them for debugging the queries. And exporters, it's up to them to run. Next thing important to us was, I don't know if you're familiar with democratized metrics term. We see the benefit of like the possibility to look at metric data, anyone in the company. On the other hand, we needed to separate them, and we needed to be able to tell how much they query, how much data they query, and possibly rate limit them or block them doing so. So this was another requirement for us. Special case for this was metrics of our cloud platform services. For example, we provide for the developers, they can just say, I want one MySQL cluster or Postgres cluster, S3-like storage, OpenStack instances, Kubernetes cluster. And all those export their metrics. And this is done by the engineers, or infrastructure engineers running those services. Before our platform was built, every service had different way how to get their metrics and how to alert on it. And we wanted to avoid this, because developers needed to federate their metrics. All the data were copied, and it was federated from different Prometheus, so it was kind of complicated to get those data. And last thing, central configuration management. We had formerly really good experiences. Like you heard a talk before, GitOps principle for the configuration and mainly for the alerting rules. And Alert Manager configuration is really useful. There's plenty of tools that you can use for the testing and approaches. So this was another thing we want to have. Also, we use JSON heavily for sharing some of the alerts or configurations. So how is it going? The happy path. The user just requests a new tenant in our platform. We create it, and then it's all you have to do is create namespace, add a label with name of the tenant, and deploy add with the Prometheus-operator's CRDs, and that's it. Prometheus will be automatically spin up. It will be configured to scrape the data and sends all those data to remote storage and to alerts to Alert Manager. The tenant gets this UI unified, so he can easily access any component we provide him. How this is set up, we have one central proxy, actually Envoy proxy, that manages all the routing and authentication authorization. Then custom operator, which configures the Prometheus custom resources for the Prometheus operator that runs the actual Prometheus. Prometheus send the data to, we use Mimir as the central storage, but I think you should be able to achieve this using Thanos or other storage, like external storage solutions. We use Mimir query federation to access the data. Like Mimir supports multi-tenancy, and this was one of the reasons we choose to use Mimir at the time when we started this. And the query federation between tenants is a really useful feature for us, and we use it heavily. And each tenant has own Grafana instance, so we can upgrade individually, because it's no easy way sometimes, an easy thing. And under one central Git repository. So what's the size of the setup? We have around 70 tenants. You see the numbers. You can read them yourselves. There's a lot of rules. This is caused by using JSON. it's easy to generate the rules. So sometimes users generate lots of rules instead using selectors or with regexes or something like that. So everything is rainbow and unicorns and shiny and works nicely. Well, of course not. So let's talk about what went wrong or what were the pitfalls we fell into. One of the biggest issues for us is remote write, and its nature. Yeah, I state the most important issues we bumped into with remote write. I will go into depth to some of those. So prioritization of new data and the duplication. Since we use Mimir, it has a feature named HA tracker, and it does the duplication of the data. So we have 2 Prometheus instances sending the data to remote write, and it drops one of the data. So those data are sent for no reason. They're just dropped. So this is one thing. It's definitely not optimal. And the second thing is that the remote write is ordered. And in our company, we do once per month, we completely shut down one of our data centers, and we rotate this, and we shut it down for an hour, so we can test that we are resilient to data center outages. But our users want those data to be replayed to the central storage. And here comes the tricky part, because remote write needs to replay the old data before it starts to send the new. And this is quite unfortunate. Well, it's understandable from the point of how Prometheus works, but this is, for us, it's bad, because after the outage ends, the users are interested if everything is working, but they query the data, and they can't see the newest data. Because we are replaying the data, it takes some time. So this is something we would like to address at some point. There's some idea. I won't go deeper in that. Next thing is missing data. With the Tenos approach, where you find out the queries, you know where you should get the data from. And if it fails, you know which Prometheus didn't return the data. With remote write, you don't have this. You don't know who should send the data, and you don't know if it's missing or not. So this is quite dangerous. I would recommend having a notion, some catalog of all the Prometheus running, so you can alert on absent metrics from all those Prometheus instances. Also, if you use agents and write to remote storage, the agent, at least Prometheus agent, cannot alert locally. So if you decide to not alert locally, you might end up not knowing that it's not functional. So you should probably deploy at least small Prometheus for monitoring of the monitoring. Next thing is scaling Prometheus. As I said, we decided that we want to manage the Prometheus for our developers, but there's always the capacity planning. We don't know how many data they will have, and it can change over time. I would definitely recommend using auto-scaling for this, because we haven't done this yet, and it's a lot of manual work, which is really bad. And we want to tackle this, definitely. So make sure to automate this. Also, with the scaling of the Prometheus, there are some limits. Scaling, I talked about, was vertical, but you will eventually bump into limits of the vertical scaling. So sharding might be difficult with combined with local alerting, because you need to know where to put the rules and where the metrics the rules should alert on. Next thing, issues caught by the users. I talk about leaking of unique values. We saw rate limiting on OpsGenie's side that there's too many alerts, failing rules due to too many errors. Those are things that do alert us, and we need to notify the users so they fix it. So make sure if you manage Prometheus for any user, to notify them about those errors and apply some limits so you can avoid those issues. And the last thing, calculate the price, because in company, sometimes the price of some service is the only way to pursue anyone to do something. So I definitely do recommend this. What's next for us? We would like to make the remote write more resilient, because every month we have issues with the replaying of the data after the data center outages. As I mentioned, we want to provide also external black box exporter from some cloud services. And yeah, there's some things we want to look at, but that's it probably. And that's it for me. Thank you. Yeah, there's QR code for the slides if you want to read those walls of text.
Thank you so much. Amazing, amazing talk. Any questions for Mark? Yes.
Thank you, Mark. Nice drawings, by the way.
Thank you.
I was wondering, like you mentioned that we should try to alerting on as much as we can on local Prometheus instance, which makes sense. But how did you guys handle the use case where you have like users wants to mix the metrics, like platform metrics that you're collecting for cloud services and application metrics? Are you alerting on central place, or like how do you handle that?
Right. The alerting usage of the other cloud services metrics is allowed only on the central storage. So yeah, this is limitation, because we would otherwise need to somehow mix the metrics on the Prometheus level. So yeah, we recommend alert, or it makes sense to alert locally, but also we have this is the limitation that we don't want to duplicate the data. So you need to alert on those query federated data on that central storage.
That's cool. And do you have any automatic way to identify that, okay, this alerting expression is using metrics from, like, I don't know, different data stores? Then this means that needs to go to these alerting evaluation.
Actually, I'm author of the PromRuval tool presented before, and there's one, actually, exactly for this, I added validation where you can state Mimir uses, it has custom configuration field on the rule group called federated tenants, no, source tenants, sorry. And you state the names of the tenants you need for the query. And I added validation where you can state like name of the tenant and regular expression matching metrics they provide. And this is run in CI. So it will tell you that you need to add those. If you are trying to use those metrics, the CI will fail if you don't have the stated tenant name there.
Hello, Martin. Thanks a lot.
Right.
I'm here.
Yeah, see you.
Thanks a lot for your talk. Awesome talk, by the way.
Thank you.
You mentioned three very interesting points. First, you have almost 200 million active time series, right?
Right.
Then 80. Yeah. Second thing, you're running Mimir. And third thing, you have 3 physical data centers. And I assume you have Mimir spread across those 3 data centers since you shut one down every month. So on this scale, how much traffic do waste replicating data across those data centers on Mimir? Because I did some calculations myself, and it should be pretty enormous amount. Thank you.
Right. Yeah, the traffic is quite big, definitely, because you need to send the data the same data to all those data centers. We have one data center is one availability zone in Mimir for us. So we are actually sending the data to all 3 data centers. The thing is, since we are on-prem, actually the network isn't concerned for us. And yeah, it isn't the same like in, I see that in the cloud, it's a huge thing, and for us, we don't care. I don't suppose that's the thing you wanted to hear, but
Cool. Like you were mentioning about data replay and so on. Did you guys consider maybe remoting writing for something like Kafka or something like that, and you can replay from there, so you don't need to?
Well, yeah. One thing is, I think Grafana and Mimir, actually Mimir is working on something like that, ingestion using Kafka. I think, I heard yesterday that that's more of because of reduction of communication between data centers. I'm not sure. It might work as a queue. I had there was idea about the remote write. Yeah, there's the right thing, implementing sidecar to the Prometheus, which would elect the primary replica of the Prometheus, send just from one of this, and actually it could have a queue on the local Prometheus scale and replay the data as out-of-order samples lately. So it can primarily send the most recent data, and if there's throughput, if there's enough bandwidth and capacity, it will send the old data later. But that's just idea, and I'm not actually sure if this would be a good idea. I would like to discuss it with someone here.
Okay, thank you for your presentation. When you mentioned about the Prometheus sharding, do you set some specific number, or you use the by default by Prometheus?
I'm sorry.
On the sharding problem that you...
Sharding?
Yeah.
Oh, well, the limit is size of a node, I suppose. Do you mean what is the size when you have to shard?
If you are using a cumbersome number, because by default on the Prometheus I think is 100. I don't know of number of shards, and I want to know if you use some cumbersome number for this.
Sorry, I was talking about sharding in Prometheus instances.
Okay.
Not
great.
shards in the remote write.
Oh, nice. Thank you.
Maybe I wasn't explicit about it. Sorry.
First of all, really nice slides. You mentioned putting a price on metrics or a price on resource usage. I assume since you have like independent deployments per tenant, it's relatively easy to do. But how do you track that? Let's say when you talk about an aggregation layer, how do you count how much resources a single tenant uses? And do you actually act on that data by imposing a budget or something like that?
Yeah, so we don't have set up we have per tenant Prometheus, but the central storage, the Mimir instance, it's just one huge cluster for all those 200 million time series. And Mimir exposes metrics per tenant, per user. So we do the billing based on this. For example, I stated there some of the resources we bill. It's sample scrape. This is from the Prometheus, because users don't have to use our managed Prometheus. They can send the data directly. So this is for billing of the managed Prometheus. Then there's the send to remote storage samples, which is exposed by the distributor, the number of samples, rate of samples sent over the remote write. And it also exposes, for example, number of bytes that it needed to fetch from indexes and chunks per query, per user. So we can bill on if you bill number of requests, it doesn't actually reflect how heavy the queries are. So if you bill by this, like the number of bytes fetched, it should be more precise. So we use this, for example. I don't know if I answered your question. Yeah.
Any other, maybe last or two questions? Yes, let's go.
I quite enjoyed the talk. Maybe some question to like the operations behind it. So you said like I think 750 Prometheus you manage.
Right.
How do you operate that? Do you have like a custom operator deploying the operator and like the Prometheus into the remote cluster?
Yeah, we have custom operator which watches namespaces in the Kubernetes cluster, and if there's a namespace labeled with a tenant name which does not have Prometheus running already, it will create Prometheus CRD, and then it's all Prometheus-operator running, and we deploy to the clusters automatically using CI.
And how do you do upgrades all at once, or do you have like a...
Yeah, mostly. No,
Okay.
no, we will choose few clusters where we upgraded Prometheus manually, but thanks God, maintainers of the Prometheus does really great job, so there are not many issues
That's good to hear.
with this.
Any other question? I have one for you, Martin.
Right.
Like, do we have open issues and discussions about some remote write client improvements you chatted about? How we make progress there?
So if we open some an issues
Do we have any pending discussions on improvements? Yeah, do we have an issue open at least?
about the ordering, I think not.
Yeah, let's do it. Let's do it.
Okay.
It's just nothing, wasn't on our radar in terms of priority. And it's also like client side. There is literally not much on the protocol side which forbids that kind of like
Right.
logic. So let's do it. Let's
Okay.
Do it.
Yeah, great. I'll do that.
Right. If there are no more questions, then thank you so much, Martin.
Yeah, thank you.